See, what is the meaning of this word steady state analysis? What do you think? What is the meaning of this word steady state analysis? Sir? Stable. This word stable has different meaning.
It does not have the transient
Transient, okay. So the basic idea of this word steady state is an AC signal is given. They don't talk about DC. The word steady state is usually attributed to this AC input, and that AC input has been given for a long time before and will be given for a long time to come. So it is a AC input continuously given for a long duration. It's not that just now switch turned on. Switch has been turned on for a long time, and some more long time it's going to be given. So that is the case. We use the word steady state. The steady state word is, if you read very good books, they usually attribute this to a word called time harmonic. Why do they do this? Whenever you use the situation of steady state, you can take Fourier transform. That is a frequency domain, you can push it. You can push a time domain equation into a frequency domain whenever they say the word steady state. So what are the notes you should make? The word steady state is usually attributed to a AC signal which has been given for a long time, and it will be given for a long time to come. We are not talking about transients. There are no sudden changes. There are no switches there. So that means whenever you are doing steady state analysis, you will never encounter a switch. But when you are doing a transient analysis for the same AC input also, there are some AC transient analysis, DC transient analysis. You can have a AC signal, turn a switch on, what will happen? Turn a switch off, what will happen? That's a totally different analysis. That is also there. But here we are primarily interested in an AC signal. It has been given for a very long time before, and it will be given for a very long time. The primary purpose of doing this is transients happen once in a while. Just now you have turned it on. But afterwards, what happens is a steady state case. So it is applicable in lots of real world conditions. So it is something that we do. And what is the benefit of it? You can directly do frequency domain analysis. If it is a transient analysis, you cannot do frequency domain analysis. You have to do something called Laplace transform, and then you do transient analysis. Okay, so here we can do frequency domain analysis. In other words, we don't need an S transform. If you're talking about a digital discrete systems, you don't need a Z transform. You can directly go for a DTFT or DFT systems. So here we are going to go into this Fourier transform, Fourier domain. That's what we are going to do. How are we going to do? By the way, what is the differential equation for this? What will be the differential equation for this? V out by V in. So it will be XC by XC plus R, and that XC is 1 by JC omega. Here only I made it Fourier transform. The moment you see J omega, it's a Fourier transform from differential equation. So this is the V out by V in. Thought I'll take this simple problem, this simple situation, to explain a steady state analysis. Now this is straightforward, nothing great about it. So how did I get the XC by XC plus R? Potential divider equation. Two impedances are there. This impedance divided by total impedance. This impedance divided by total. What is the impedance offered by capacitance? XC, which is 1 by JC omega. So XC divided by XC plus R. That's how I got this equation. And the next is, now let us say I'm giving an AC source. I mean, of course, it has to be an AC. We do this analysis understanding that it is an AC given. Let us say the AC frequency is 10. Well, sorry, gain is the amplitude is 10 sine omega t where omega is a, let me give some frequency, 2 pi into 2 pi f, right? Let us say the frequency is 1 kilohertz. So this is the source. Tell me what is the output. Let us give some values for R and C. Let us say R is 1 mega ohms and C is 1 kilohertz, 1 kilo ohms, 1 microfarad. Tell me what is the output V out. I've given you this. I've given you omega value, R value, C value is given. V input is also given. This is the V input. Tell me what is V out. Spend a few minutes. I'll try to explain things that we need for this exam, this part of the exam. See, first thing, how did I get this? This equation is also called transfer function, if you are looking at from some viewpoint. But usually, transfer function word is reserved for S domain. You can just say this is a gain equation. They call this as a gain equation, output by input, system equation. See, if you have any doubts how I got this, you should spend some time. You can ask me, I can explain again. How did I get this? If you have two impedances, we did in the morning session. If you have two impedances, what do? R2 divided by R2 plus R1. We did this, right? We have two impedances, R2 divided by R1 plus 1 into input. That is the output. So output is this impedance divided by total impedance into the input. It's the same thing I did here. Output voltage is this impedance divided by total impedance into the input. That input I brought it here. Basic potential divider equation. We have two impedances. Z2 divided by Z1 plus Z2 into Vi. So that's how I got this equation. And I started with the frequency domain form of capacitor equation. It's C, which is 1 by JC omega. Then I got this gain equation. Now comes the situation. Input is 10 sin omega t. If it is 10 sin omega t, what will be the output? Substitute the value of R and C. Substitute the value of omega. I want you to plot V out corresponding to the input V. This is a very basic thing, right? You have to know this. What is the V out, sir? So R into C will be 10 power minus 3. So V out is 10 sin omega t divided by 10 power minus 3 j omega. Substitute the values of omega plus 1. Now this is a complex number. A complex number will have a real and imaginary. Can you split this into real and imaginary and tell me what does the final answer look like? By the way, what is omega? 2 pi into 10 power 3. So you are going to get 10 sin omega t divided by 2 pi j plus 1. Now what is this magnitude of 2 pi j plus 1? Let me first talk about magnitude. What is the magnitude of this? Can you find out? What is this magnitude? 6 point? No, denominator, right? Bring it to the numerator. 0.157. So it is multiplied by 10, you are going to get 1.57 sine omega t. It's not complete. What is the phase angle for this? How will you find angle for this one? How will you find angle for a complex number? Tan inverse of imaginary part divided by real part. Now it is in the denominator actually, so you should put minus tan inverse of. What will it be? Tan inverse of imaginary part 2 pi. So tan inverse of 2 pi. What is tan inverse of 2 pi? Tell me in degrees. Degrees. Not in radians, I want it in degrees. $80.95. So the meaning is minus, right? 80.9 degrees. So this is the output. So the output is this one. See if you understand this. What is the meaning of this? Make a note. I'll draw a sine wave. You will understand. It's nothing great about it. See, the meaning goes like this. If you give an input like this, see the white color is the input. What is the output? Output amplitude 1.557, but it starts at exactly how does it go? Stay there. See, this is the V out. What do I mean by it? If you have an RC circuit, if you give 10 sine omega t in 1 kilohertz, because this is 1K and this is 1 microfarad, the output is like this, only 1.57 volt, and again there is a phase delay of 80.9 degrees. What is the meaning of this complex numbers magnitude and phase? What is the meaning of this amplitude and phase? The amplitude, I mean the magnitude of this decides how much will come out. Will the whole 10 volt come out? No. This says only 1.57 volts will come out. Will it come out in phase? What is the meaning of in phase? If I give input now, will it come out now only? The answer is no. There is a phase delay. What is the meaning of phase delay? It takes some time to come. If I ask you how much time it will take, what is your answer? 80 degrees, it is in degrees. I want it in seconds. How will you say how much time it takes? Phase delay means it takes some time to come out. How much delay? I said it will come out. If I give now, it will come out here. This is 80 degrees. It is in degrees. So what is the x-axis? It is omega t. I want it in seconds. 1 kilohertz means what is the time period of the signal? 1 millisecond. So that means here it is 1 millisecond, right? In 1 millisecond, one cycle is over. So this will be 0.5 and this will be 0.25. So this is approximately 0.25 milliseconds. You understand? 90 degrees is 0.25. So that means if you give now input, it's going to come out after some time, and that some time is 0.25 milliseconds. So what is the meaning of the phase delay or the phase of that complex number? It will tell you how much delayed the signal will come out. That's all I wanted to say. This is steady state analysis. You should be able to find the magnitude and the phase. So to be more specific, if I ask you time, how will you find time? Omega t is 80.9 degrees. Then omega is what? 360 degrees into 1 millisecond. Sorry, F, right? 1 kilohertz into time. So what will be time? So you have to find exactly. Why did I put it 360 instead of 2 pi? Because this is in degrees. So I put this also in degrees. So what will be time? Then find out. What is this time? I asked you a question, right? What is this time? 80.9 divided by 360 into 1 millisecond. 0.2247 milliseconds. Now, if you have any doubts here, you can ask. I'll extend this discussion a little bit more. Now, let us say I'm sending my voice signal into this. My voice signal has, let us say, usually it is kilohertz only, 1 kilohertz and 2 kilohertz. My voice has two frequencies, not single frequency. It has, say, just it has much more multiple frequencies. Let us say 1 kilohertz and 2 kilohertz. In 1 kilohertz, let us say it is 10 volts, and in 2 kilohertz, let us say it is 2 volts. Can you tell me what happens here? For the 1 kilohertz, how much will come out? How much amplitude will come out? We just found out how much will come out. For 1 kilohertz, it is 1.57, and the angle is minus. You understand the meaning of writing like this? And 2 kilohertz, what will be the answer? Tell me what is the amplitude and what is the angle? How will you find out, by the way? You have to substitute here. Omega 2 pi f, sorry, f is 2 kilohertz. That means this will become 4 pi. What will be the amplitude?
0.079 at an angle of minus 85.43
0. 0.07.
79.
You multiplied by 10,
Almost.
that means 0.79, right? So the amplitude here is only 2, sir. You should multiply by 2. How much is it? Point. What did you get? Correct. So you should be getting 1 by 4 pi j plus 1. What is the magnitude for this? Into 2. You should multiply by 2. This is all I care about. For 2 kilohertz.
0.158.
0.158. And angle is?
Minus 85.4.
So what we understand is which one gets attenuated more. Here the attenuation for 1 kilohertz is less. For this one the attenuation is more. For example, if you try to multiply by 10, maybe I should have done that one. If you try to multiply by 10, what you would have got? 7. So that means this one gets more attenuated. This one gets less attenuated. And this one comes little bit delayed. This one comes more delayed. So what we understand is my voice before sending to this one will be like this. After sending it will be different. You understand? Because this one got more attenuated. This one got less attenuated. So my voice will be somewhat like this. If you say the resultant voice will be, it has no match to the actual signal. So what we ended up getting is, I just wanted to make 2-3 points. That one point is each frequency will have its own gain. Each frequency will have its own delay. So the signal the output signal will be different. We don't call it different. There is a specific word for that, and that is distorted. This is what we call as signal distortion. What is the meaning of signal distortion? I have a shape before giving to the system. After giving to the system, I have a different shape. One of the primary reasons for this different shape is nonlinear phase. What is the meaning of nonlinear phase? What is the phase we got? Tan inverse of imaginary by real. Tan curve itself is non-linear, right? It's not linear. How does a tan curve look like? It's a non-linear curve. So this is a non-linear phase system. A non-linear phase system will eventually distort the signal. That is why when you are studying signals and system, we are more interested in linear phase systems. Have you studied this word, linear phase system? Whenever you study signals and system, or maybe digital signal processing, they'll keep saying that linear phase system. We like linear phase systems. At least we try to correct the non-linearity after post that. The purpose of that is the signal distortion can be avoided. A linear phase system will have a non-distorted signal. Anyways, that's outside the scope of this class. The point here I wanted to make is each frequency will have its own gain and its own phase difference, phase delay, or phase gain, whatever it is. Okay, I hope you have got some idea on it. Maybe we could check how much you have learned. Okay, there is a question here. All right. This is 2004. See if you can solve. Similar RC circuit. Here they have given RC is 1 millisecond. Somewhat like previous problem, I guess. They are asking what is V out. Options are What is the answer? Say all the options. What is the only difference? Phase is only difference. So don't waste your time with amplitude. Just tell me what is the phase difference. Option. So whatever we have discussed till now is sufficient to solve almost all the problems. I just want to, we will prove it in short while. We will try to solve most of the problems, but this is sufficient. How will you go about it, sir? We already did. What is V out by V in? 1 by RC j omega plus 1. We are only, say, I'm only interested in the phase of V out by V in. What is the phase of it? Minus tan inverse of imaginary RC omega divided by real part 1. Because it is in the denominator, the complex number is in the denominator, I put minus tan inverse of. Now substitute RC omega. What is omega here? 10 power 3. What is RC? 10 power minus 3. So minus tan inverse of 1. What is minus tan inverse of 1? Minus 45 degrees. So it is option A. First, you should write the gain equation, that is output by input. It's a complex number. From that, how do you find the uh, phase? How do you find phase? There are lots of such problems. Get another question. A quick question. Now, what is the omega here? 2. In the output, can I get 3? I'm asking, if you give one frequency, can I get a different frequency at the output? What makes you say that?
Sir,
On
the
what
total-
basis you are saying?
Sir, the total HCCT remains the same.
Why?
It delays gets delayed only, sir.
Why? That's fine. Why? Do you think it is always like that? I give a frequency at the input. Do you think at the output I can have a different frequency? The answer is, whenever you use linear components only, you cannot have new frequencies. A non-linear component produces new frequencies. Just make a note, leave it for now. Since RLC all are linear components, you cannot have new frequencies. Whatever frequency you give at the output, input only will be available at the output. Only non-linear components can produce a new frequency. How will you find this one? If you have parallel components, how will you find the net impedance? 1 by Z equal to? Yes, sir. Correct. 1 by Z equal to 1 by R, 1 by XC plus 1 by XL. It's not L, it is 1 by XL. Now that is equal to I by V. Agreed? The net impedance 1 by Z is 1 by R plus 1 by XC plus 1 by XL. Z means V by I. 1 by Z means? So I by, you know V, you know all these things. You just have to find I. Basic complex number stuff. I'm sure you can do it. What is XC by the way? XC is 1 by J omega C. Voltage is given, they are asking you to find current. First make it a single complex number. ஒரு single complex number வந்துச்சுன்னா ஃபேஸ் கண்டுபிடிச்சிடலாம். tan inverse ஆஃப் போட்டு இமேஜினரி பை ரியல்னு போட்டு ஃபேஸ் கண்டுபிடிச்சிடலாம். What is the complex number you are getting? Sir? 3 plus 4j. Excellent. 3 plus 4j. Now, what is the magnitude of it? What is the phase? Well done. So, what option will you choose? Very good. Option A is correct. என்ன பண்ணிருக்காங்க பாருங்க சார். அவங்க என்ன பண்ணிருக்காங்க, நீங்க ஏதாவது தப்பு பண்றீங்க அப்போ. XC means 1 by JC omega. XL means it is not 1 by L, 1 by C. It is 1 by XC, 1 by XL. Be careful with it. Usual mistake, don't do it. You're not getting, sir? பாருங்க இவங்க என்ன பண்ணிருக்காங்க பாருங்க. How to handle complex numbers. So actually you should have got, what is the complex number? 3 plus 4j. So finally magnitude 5 sin omega t, 5 sin 2t, phase magnitude is 5, angle is tan inverse of 4 by 3. See, this is the input, this is the complex number. You understand? Omega is 2. How did I say omega 2? Sin 2t. Omega is 2 because sin 2t, L value given, C value given. All of the sudden this complex number will be absorbed by the sign. The complex number will be absorbed by the sign. How is it absorbed? The magnitude goes here, phase goes here. All right, so this is something that I hope you have done. Maybe I could do some more problem on this. Make sure that you have got it properly. Write a KCL. That's all. You will get the answer. 3 branches are there. Write a KCL. Where will you start this? Only one thing is there, as we said, KCL. Write KCL at this node. Let us say Vx node. Write KCL at this node, Vx. It's all right. You will get the answer. See, if you know this voltage, no, you can find this current. If you know Vx, Vx divided by 1 ohms is I. Find Vx. How will you write KCL equation? Vx minus 20 divided by
XL.
XL, not L, XL. And Vx divided by 0 divided by
1 ohm.
Vx divided by 0 divided by Xc. Finish. That's all, right, KCL. So we have been writing KCL for DC sources in the morning and only for resistors. Now we are doing it for AC source and inductor and capacitor. That's all. There's the only difference. Morning session only DC, now AC. XL. XL means J omega L. XT means 1 by JC omega. I'm going to write KCL. First point, there are 3 branches. So it will be Vx minus 20 force angle divided by XL plus Vx divided by 1 plus Vx divided by Xc. See if everybody gets this first. This you should be able to do. Find out XL, find out Xc. You would have got Vx.
The Vx minus 20 by x and the current only get divided into the two. Should be like Vx minus 20 equal to Vx by 1 plus Vx by x.
Sir, you are saying this current only get divided by 2.
Yes.
Not divided by 2. It is getting divided. I don't know how much going here, how much going here.
Okay.
Equal division for all. What is XL, by the way? 20? 20J. What is XC? Minus J 20. That's all. Substitute. Finished. Equal to 0. So this is a pure complex number problem you should be able to do. Fine, sir. What is the answer? Option? Correct. Sir, in the classroom you should solve complex numbers. Complex number handle பண்ண கண்டிப்பா தெரியணும். அது தெரியாம எப்படி? So this is Vx. Pure complex numbers. There's nothing great I have done. I just took this 20J common. Vx minus 20 minus Vx will get Vx cancel. Minus 20 by J 20. So 20 cancel. 1 by J. Once you know Vx, what is I? V by R. R. So it should be one by J can be written as minus J. 1 by J can be written as minus J. So what are the new things you should have learned? 1 by J can be written as minus J. Complex numbers. That's all. That's all. This is what is given. R is given, R is not given, L is not given. You'll have to find L. Voltage is given, current is given. This is 2020. One more question. If you know V and I, what is given in the question? V is given, I is given. If you know V and I, what is V by I? Z, input impedance. V by I is Z. What is the Z for this R plus J omega L? அவ்வளவுதான் முடிஞ்சிருச்சு. V by I equal to Z, which is equal to R plus J omega L. They are asking L. See, R plus J omega L is a complex number. No. What is the magnitude of it? Square root of R square plus omega L whole square. And what is the phase of it? Tan inverse of? Go ahead. That's all. Okay, where will you start? If you have a R and L, what is the net impedance? What is the net input impedance? R plus J omega L. And this is also equal to V by I. Now, what is V by I? 200 cos phi t divided by 10 cos phi t minus 45 degrees. I will write it in degrees. It's easier to handle. Now, can you convert this to a complex number? Magnitude and phase. இவ்வளோ நேரம் நம்ம காம்ப்ளெக்ஸ் நம்பரை சைனுக்குள்ள எடுத்துட்டு போனோம். இப்போ சைன்ல இருக்கிறத காம்ப்ளெக்ஸ் நம்பரா மாற்ற முடியுமா? What is the magnitude of this? 20. What is the angle? Plus denominator இருக்குல்ல plus 45 degrees. See, I converted this to a complex number. Now you have a complex number whose magnitude is also known and phase is also known. I converted this to a polar form of complex number, not a Cartesian form, polar form of Cartesian, polar form of complex number. How did I get the magnitude, sir? How did you get magnitude? 200 by 10. How did you get the phase? I see in the numerator there is no phase. In the denominator it is 45. So I say negative 45. So when it comes to the top, it becomes plus 45. So understanding this is very, very important. How do you get a complex number from a simple sinusoidal signal? Magnitude and phase. So what is the magnitude of this one? Square root of r square plus omega square L square. What is the face of this? Tan inverse of omega L by r. So you know the face, you know the magnitude. So this is a basic, purely complex number stuff. Nothing to do with network theory or circuit theory. I think omega value, it is 5. See, tan inverse of what value will give you 45 degrees? 1. So omega L equal to R. Omega L by R equal to 1. So you know omega L equal to R. Simple. You have two variables, two equations. You can solve it. Complex numbers. Tan inverse of 1 is 45 degrees. So omega L equal to R.
So 1.26.
Which one, sir?
L.
No, no.
2.8.
Sir, 2 root 2. Multiply பண்ணுங்க sir. Multiply பண்ணா என்ன வரும்? 2 root 2. 2.8. 2.8. Correct. Sorry. 2.828 is the correct answer.
Yes, 2.8.
So what you should have understood? Tan inverse of 1 is 45 degrees. So omega L by R is 1. Omega L equal to R. Substitute it here. Okay. So it should have been 20 equal to square root of R square plus R square, which is R root 2. From this you can say that R is 20 by root 2. You can find R whatever you want, which will also be equal to omega L. Okay. And you can say omega L root 2 is 20. Omega is 5. L equal to okay. Can you tell me what is the component here? I gave you V and I. What is the component here? How did you say inductor, sir? Voltage leads current. Is it only inductor or resistor? How do you say that? Exactly 90 degrees. Okay, sir. If it would have been, what happened to the previous case? It is 45 degrees. So there is some resistance. I can say something else. Now what can you say about it? It is a RC circuit. How is that RC circuit? RC, okay. How is it? Is it like this? RC circuit. I'll stop it there. It's not V in, V out, right? So it is V and I. Okay. All right. So these things should have given you some fundamental idea about this steady state things. It's also one tricky problem. It's 2020 again. So two more question. See if you can solve it. All the three impedances are same. Z, Z, Z. Z value is given. It's not three different impedances. It is the same impedance. Write KCL, sir. That's all, nothing. Just write KCL. KCL for that node. இதுக்கு ஒரு KCL எழுதுங்க சார் இந்த நோடுக்கு. See, if you are taking this as a reference voltage, இது 0 எடுத்துக்கிறீங்கன்னு வைங்களேன். அப்படின்னா என்ன எப்படி எழுதுவீங்க? இதுவும் 0 வோல்ட் தான். 0 வோல்ட்டுக்கு KCL எழுதலாம். எப்படி எழுதுவீங்க? 0 let us say that this current is getting divided. What will you say? 0 minus this voltage divided by Z plus 0 minus this voltage. How will you write KCL? 3 branches are there. So I equals, I the incoming, outgoing. What is the current through this branch? 0 minus, what is the voltage? 120 minus 90 divided by Z plus 0 minus 120 minus 30 divided by Z. Now the problem is, this is a complex number. What is the number you know? This is in the polar form. Bring it to the Cartesian form. எப்படி பண்ணுவீங்க? We did it, no? You can do it with calculators. You can do it. It is just in the polar form. You can make it a complex, a Cartesian form. You will end up getting a simple complex number by complex number, complex number by complex number. It's all basic calculator stuff. What is 120 minus 90? Complex number. See, there are multiple ways to do. One of the way is you can also convert this to a form. What will be the polar form of this? 87.32 and angle is minus 23.6. So you can do that like that also. Minus 120 minus 90 divided by 87.32 minus 23.6. Minus 120 minus 30, 87.3 minus 23.6. So what do you do here? Magnitude you can cancel. How much will you get? 120 by 87.3. Okay. Many ways of solving complex numbers. 120 by 87.3. 1.37. And how about the angle? The denominator angle, when it goes up, it becomes plus. So 90 minus 23 is what? 66.4. 66.4. And you can do the similar way here, 1.37, 6.4. How do you add these two? Bring it to Cartesian form, add it. How did I do this, friends? First, I divided the magnitude part and I took it up. I just subtracted that from 90. Basic complex numbers. So what is the answer? Final answer is what is minus 1? Minus 1 is 180 degrees. So you can take this. Okay, tell me what is the final answer you are getting, sir. Minus 2.3, is it 2.4? 74, is it? You should be getting 2.38. Okay, 2.74. And what is the angle you are getting? Sorry? Better check. See, convert this to a Cartesian form and see. You'll be getting this. 2.38 angle, yeah. So you should be getting 2.38, 140, option D. How to handle the magnitude phase of a basic complex numbers. There are two forms of a complex number. One is Cartesian form, the other is polar form. How to jump between them, all these things you should know properly. You're not getting, sir? Same numbers? All right, then. There is this locus of the phasor. I found a problem on that. When omega is varied from 0 to infinity, find the locus of the current phasor. Options are given. So 2 mark question. There was lots of such question for electrical also. Where will you start, friends? We should start with x, finding the xl, xc. Don't keep it as L and C. Convert it to XL and XC for each frequency. What are the frequencies here? How many frequencies are there at the input? Two frequencies. What are they?
200.
Omega is 200 in one case, in the other case it is 500. For omega 200, find out what is XL, XC. Again for omega 500, find out XL, XC. Don't keep it like this L and C. The moment you convert it to XL, XC, it will become very easy. Because you get J, right? Most of the cases they will get cancelled. Minus J will become plus J will be cancelled by minus J, like that. First omega equal to 200. When L is 0.25, what will be omega XL? When omega equal to 200, what is XL? J, okay, J50. And what is XC? Minus? Sir? So for 200, omega equal to 200, what is the value here? When omega equal to 200. For omega equal to 200, XL is 50J and XC is 1 by jc omega, sir. Xc is 1 by jc omega.
$500 minus 500J.
Minus 500 or 50, sir. Be careful. Is it very difficult? It is 1000 divided by 2. 500. Yeah, you are correct. Minus 500 J. And how about this one? 200 into J omega, right? So that is fine. So this will be minus 500 J. And how about here? Here, this inductor, 200 into this one, 80 J. So this XL is 80 J. And here this one, this one, sir, same, minus 500 J. So what will be the net impedance? Looks like, what will be the net impedance here? When you do parallel of these two, 80 and 500, what do you get? For 200, how about 500? So it will be what will be this one? 500J parallel with 80J. I'm just talking about 2 cos 200 omega t, 200 t. What will it be here? How much is this?
Minus 95.238.
J. So what will you get here at the end? And similarly, how about this omega equal to 500? When omega is 500, what will happen here? It is 0.25 into 500. How much is it? 125J. 125J. And how about the capacitor thing? Capacitor will be minus 200J. Did I give question correctly? Sir, this is 100, sir. I'm sorry for the mistake. This is 100 microfarad. If it is 100 microfarad, this will be 50J. So what will you have? The problem here would be 0J, that is short circuit. So what will you get? You don't have to worry about this. V output equal to V input. And how about here? Here this will become this is 100 meters. This is correct. This is correct. Here only I missed 0. I'm sorry for the inconvenience. This, what will this become when omega is 500? This will be 500 into 10 and 5,200. This will be 5,400. So you will end up having plus 200J minus 200J. Okay. What is this when you have plus 200 minus 200? Net impedance. Sir? Multiply and then how will you find Z2? Z1 into Z2 divided by plus Z2. What is the net impedance? Infinity. So this will become open circuit. This became short circuit in this frequency. This became open circuit. So what does it mean? If this branch is not there, what is V out? This is there. What is the relation between V out and V in? V out is V in. In this case also V out is V in. So what is the answer? For this frequency, this will become short circuit. For this frequency, this will become open circuit. So effectively, when this is short circuit, whatever comes just will flow. When this is open circuit, irrespective of this impedance, it will just flow. So the answer is option B. See, this is a mistake actually. It is only 50J. Plus 50 minus 50. So it's a short circuit. Zero resistance. There are two input frequencies. One is omega is 200, the other is omega is 500. In both cases, this impedance network is designed in such a way when omega is 200, that resistance is becoming short circuit. Just to explain what is happening, if I say V in, V out, what is the relation between V in, V out in this case? And in other case, this is open circuit. What is the relation between V in, V out? When this is short, do you think this resistor will matter anyways? Voltage across junctions are same. So whether this junction or this junction, the voltage is going to be same. So V out is equal to V in. In this case again, will this resistor eat any energy? That here it will be different. You understand the question? Will this resistor play any role in changing the impedance here? Yes, no. Sir, there is no current flow. See, if you are trying to measure voltage here, right? What is the device used for measuring voltage? Voltmeter. What is the input impedance of voltmeter? Infinity. So it is not going to consume any current. Is there any other path for the current to flow? No. So the current through this is 0. If the current is 0, what is the voltage drop across this? 0. So all the voltage will appear here. So in both cases, V out equal to V in. Here any amount of current this fellow resistor wants, this will still maintain the same voltage here. Here there is no need for current to flow here at all because there is no draining path. This fellow is not going to consume any current. There is no path here. So the resistance is 0. All the voltage will appear at the output. So in both cases, V out equal to V in. That is why I said option B, which is V out equal to V in. For one frequency, this part is short circuit. The other frequency, this part is open circuit. Think about it. If you have anything, if you want me to say it again, I can. All right. We'll move on. There are some more problems. I think tomorrow we'll do. For now, I'll just move on. We'll just introduce this part. Some basic I will introduce. What is the basis of a two-port network? Two-port network. What is the basis of it? Why do we study it? The basis of this two-port network or any multi-port network is, how do we put it? Where do we apply it? Say you have designed a component and that component needs to be characterized. You think that before designing you had some plans. It should work like this. But after designing, you cannot just tell a customer that I planned to that it should work like this. So you take it. You have to tell now how it is working, right? He does not care about your plans. What he cares is how is it now. That part is called characterization. Any electronics industry will have a team called characterization team. What they will do is they will take that component. It can be transistor, whatever it is, and then what they will do is they will connect a voltage source and then they will measure current, and then or otherwise they will connect current source and measure voltage. At the end, what they are doing is they are characterizing the component. You might be thinking that the input V and I relationship is like this. Before designing, this might be your plan, but after the fabrication and all that, it might come something like this, right? So this is what is called a data sheet. You will this is what you will print in data sheet, not this one. This is your plan. The customer does not care about your plan. All he cares is what is the final product, how does it work, what is its characterization now. Now that characterization team, whatever they do is called a simple two-port analysis. He will not look into the circuit. What he will do is he will connect a voltage source and then measure current, and then he will characterize what is the situation, each and every. Now that way of doing is called two-port. He thinks of this as a black box, right? He does not think what is happening inside too much. Little bit he knows some idea, he has some idea, but he will not think too much about it. Now there are two ways to do it. One is you can have a voltage source. This is a voltage source, V source, and measure current. Ammeter I put and then I measure current. Or otherwise, there is another way to do it. What is it? You can give a current source and then measure voltage. Right? There are two ways to do it. Now, which one is preferred depends on which one is preferred. I'll give you a case where voltage source is dangerous. If the input impedance is 0.01 milliohms, you give 1 volt, how much current will go? 1 divided by 0.01 milliohms, which is 10 power minus 5. So 1 lakh amps will go. In other words, you are spoiling your voltage source. So it is not that every time one is preferred, the other is bad. It depends on what is the input impedance. Whenever input impedance is less, then which is preferred? Current source is preferred. Whenever input impedance is less, for example, 1 milliohm, if I give 1 volt also, even if I give 1 milliamps, the voltage generated will be very small. So it's all safe limits. So a characterization engineer will have a fair idea of what is the input impedance, output impedance. So that will help him decide what is better to connect voltage source or current source. Now this is the introduction for a 2-port. How will you make a notes? Story is all fine, but you should make notes. After a couple of days, you will forget. 2-port means you try to characterize a component with a source and a measurement. With a source and a measurement. You characterize a component with a source and a measurement. A source can be a voltage source or a current source, and the measurement can be a voltage measurement or a current measurement. It is up to the engineer to choose wisely. So for a 2-port setup, what all I can do? For example, I measure voltage. Whatever you measure, it comes on the top, and whatever you give as source, it comes at the bottom. That is customary measurement, output by input. V1 by I2. V2 by I1 by I2. See, whenever you are, what are the sources here? No, sir. The sources are at the denominator. The point I want to make is the customary way to write is whatever are the source, they are written at the bottom. In this case, what is the source? V1, V2. Here you are. V1, V2. I1 is the measurement. I2 is the measurement. Since this is all I by V, we call it as conductance. We call this as a Y matrix or conductance matrix. And this is all impedance. We call it impedance matrix. What are the things I want you to pay attention? What are the sources here? P1 is function of I1 and I2. Because these are the sources, this is the measurement. P2 is a function of I1 and I2. When you are measuring at the port 1, you should silence the port 2. How do we do that? Pay attention, there are lots of information here. When you are measuring at port 1, you should silence the port 2. How do you silence the port 2? I2 is 0. How do you make I2 0? Make sure that no current flows. How do you make sure no current flows? What do you do? Open circuit. When you open circuit this, then you are making sure that there is no current flowing. And how do you do that here? Open circuit. And here it will be. There are only two sources. If you are working with one source, the other source should be silent. Since we do open circuiting here, we call Z matrix as a open circuit modeling. And why is as a, because you are short circuit, right? You want to silence the other. Short circuit modeling. Short circuit modeling. See, after all, how is Y and Z related? How is Y and Z related? Y is a conductance, Z is a impedance. How are they related?
Inverse.
Inverse, right? So if you know Z matrix, if I ask you Y matrix, what will you do? Inverse of that matrix. You know how to find inverse, right? So that's it. So I'm going to give you some simple circuit and see if you can get a Z matrix. If you have a circuit like this, 2 ohms, 4 ohms, 6 ohms, can you get a Z matrix for this? What is a Z matrix? This. What is Z matrix? This one. Open circuit, second port, and then give I1 as the source. Find V1. How will you do? Open circuit it. I want to find the first element. Open circuit it. Connect I1. Let us say I connect 1 amps. What is V1 here? I open circuited it. Now what is V1? If you connect 1 amps, what is the voltage you will have here? 1 amps into 2 ohms. And this 1 amps, where will it go next? 6. So what is the total voltage here? 8. So it is 8 volts by 1 amps. And also I did make sure that I2 is open, 0. Fill it up like this. Get me what is the Z matrix. The same way, Z matrix means you choose a current as a source, voltage as a measurement. You can give any amount of current, but I think 1 amps will make my life easier, so I choose 1 amps. Can you attempt the next? Other three elements in the matrix. That's all. I just do one more similar circuit like this, which is pi matrix, pi network, which is, and then we'll stop today's class. I just want to introduce this T network and pi network. Now the next case, Z12, that is this element. What is this element? I1 is open. I2 is 1 amps. Find out V1. This is 1 amps. I2 is 1 amps. Maybe I'll just give a simpler this thing because we have not done you. I just want to keep it symmetric. So if it is 1 amps, 2 to 6, and I'm measuring voltage here, what do you think you'll get? I am for measuring voltage. What is the meter you are connecting? Voltmeter. Will it consume any current? No. So what will be the voltage here? Sir, if 1 amps goes, what is the voltage across this? What is the voltage across this? 1 amps is flowing. 6 volts. Can this 1 amp go here? No. We said that voltmeter will not consume any current. So that means 6 volts. After 2 ohms, what will be here? Will there be any current through this? No. So that means the potential drop is 0. So all the 6 volts will come here. So it is 6 volts divided by 1 amps with I1 0. Go on, fill this up, fill the rest of the elements in the matrix. Just a one current source, finding the voltage. That's all. Always remember, through this element, no current is flowing. So that means potential drop across this is 0. Whatever voltage is here, the same voltage will come here. How about next here? Symmetric. So you're going to get 6 by 1. And here it will be so what is the final matrix? Z matrix. If I ask you Y matrix for the T network, what will you do?
Take inverse of this one.
You can take inverse of this matrix, you can get Y matrix. Why don't you do connect voltage source and then measure current? You can do. So that is one thing you can do. I'm not saying you cannot do, but it is always easier if you have one matrix already. Why to waste time? You can just do the inverse, which is much easier mathematically. I'll give you one trick. If you have a T network, if you want Z matrix, Z11 is this plus this, and Z22 is this plus this, and Z12 and Z21 is just the middle element. 2 plus 6, 2 plus 6 is 8, and 6, 6, the middle element is here and here. See, after all, you are giving 1 amps and measuring this only, no? So whatever this number is going to come. You give 1 amps and measure only this one. So 6 will come. In this case, what are you doing? You are giving 1 amps and measuring through whole of the network. Simply speaking, if you say R1, R2, R3, this will be R1 plus R2, and this also will be no, this will be R2 plus R3, correct, and this will be R2, R2. You would have studied this, huh? Nothing new we have discussed, all you have studied. Now if I ask you Y matrix, you know how to take inverse, so don't bother. I said I'll give you one more circuit, which will be the last for the day. And that circuit goes like this. What is asked is admittance matrix. What do they mean by the word admittance matrix? Why? Yes. The network goes like this. You are asked to find admittance matrix. Always remember, again a small note I want you to write. For pi networks, finding Y matrix is very, very easy. For T networks, if they ask anything else, for T network, if they ask Y, what should you do? Find Z and then go on, find Y matrix for this, we'll stop. For Y matrix, what is the input? Source is voltage source, and what needs to be measured is current. Follow the rules, follow the rules. What is it? Look at the matrix that we did. Give 1 volts, measure this current. You will get Y11. Give 1 volt, measure the current. Connect 1 volt, sir. Put an ammeter, connect 1 volt. So this circuit, what is the impedance? How do you make V2 0? Short circuit. So what are the impedances here? Now if I give 1 volt here, what is the current? If you short circuit this resistor, does it have any role? No. So what is the net impedance now? What is the net impedance? 10 and parallel with 5. 10 parallel with 5. So accordingly current will go. How much current will go? Go on, find out. Just one last problem. You have come for the end of the day.
Ten by three amps.
For 1 volt, how many amps, sir? No, not 10 by 3, maybe 3 by 10. So this is short. What is the net impedance? I'm shorting this, connecting an ammeter here, connecting a 1 volt here. So this will go. What is the net impedance? 1 volt, ammeter, 10 ohms and 5 ohms. 10 parallel with 5, that will be 3 by, what is the impedance, sir? 3.3. Okay, so it's going to be 1 volt divided by 3.33 ohms, which will be the current. But what I want is a different case. What is that I want? I want what is current. What will be the current? What will be the current? Uh, 3 amps. Right. So I got I want 3 amps, and this one is 1 volt. So 3 amps divided by 1. Then V2 is 0. Am I correct? I made a mistake. Please check. I think I find it's just 0.3. Point. It's not 10 by 3.3, right? It is just 1 by 3 point. Go ahead. Oh, okay. And this is symmetric. So again, here you will have 0.3. What will be here? Can you attempt this one last thing? Let me attempt. What is it? Actually, it is uh, I1 by V2. So it is I1 by V2 when V1 is 0. This is what I want to attempt. So I'm going to short it. No, no, no. What is the current we are measuring? We are measuring I1. I1 we are measuring. V2 is 1 volt. V1 is 0. What will be the current here? Very difficult. Just tell me what is this current. I'm removing this resistor because it is short. What is the current through this one? Sir? 1 by 5. So it is 0.2 divided by 1. So here it will be 0.2, 0.2. This is the answer. This is the Y matrix. So we made Z matrix and Y matrix. Z matrix, when do you make? For T networks. When do you make Y matrix? For pi networks. If they ask for a pi network Z matrix, then you will have to find Y, take the inverse. So that's all we did. And this is a small test you're supposed to conduct. I'm not going to give you any difficult questions. I just want to give something easy questions. Tell me answer for it. Maybe I'll choose questions from whatever we did from the morning. Let's start with simple KCL. Find this voltage Vx. You can just write answers at the back. Pass it on. Question number 1. Only 3 questions. See, when you go back, not here, all resistance is 1 ohm. What is the input impedance? All resistances are 1 ohm. Options are 1 by 6, 1 by 3, 9 by 20, 8 by 50. So when you go back, try to attempt this. And one more. Find VAB. 2 questions, homework. Again, all these are gate questions. See, today whatever I solved, none of the question I made it up. All are gate questions. Okay. People who gave last year gate exam, you just go and ask if they would have solved all the previous year gate questions. All the previous year gate questions, you can easily get 60 marks. You don't need anything else. Just to take a previous 30 years gate question bank, solve all the questions, you will easily get 60 marks. 60 marks means it's one of the top ranks, right? Just some 47 marks this year. I think EC department, he got some 600, 700 that rank. Okay. So that means 660 marks means you'll get top 100, less than 100. So it's a top marks. I want you to think it through. You just have to solve all the previous 30 years question bank. That's all. Nothing else is required. You might think it is easy. Actually, it requires. It's if you calculate the total number of questions, it will be around 4,000 to 5,000 questions. To solve that many questions, you will need at least 600 hours. So if anyone who has got a good rank, you just go and ask. They would have put 2 hours every day for 1 year. In other words, 600 marks, 600 hours. Without that effort, this rank will not come. So if you want good rank, this effort you have to put. Class is just starting. We solve at least 30 to 40% of the previous year questions. Rest of the 60% of the questions you have to solve. We need 600 hours of your work. After that, only rank will come.